Hello everyone, this is Mrs. Lindsay. Today we're going to talk about the chain rule. Okay, so let's start off with comparing some equations here. So we want to look at what's the difference. If you need to, go ahead and pause this. I'm going to move this down just a little bit here so you can see those bottom examples. But pause it and write these down and then push play when you're ready. Okay, so let's talk about what the difference is. So if we compare the left-hand column to the right-hand column, so here I have y equals x squared plus 1. However, on this one I have the square root of the quantity x squared plus 1. Same sort of idea. On the left side, 3x plus 2. Now I have that quantity raised to the 5th power. So in other words, you really kind of have an inside portion and then outside portion. So in other words, you have a composition functions. So I would like to say again, you have an inside and an outside function. So the inside portion is this quotient. The outside function is raising it to a power or squaring it. Okay, so an inside versus an outside part of the function. Okay, so how do we actually handle taking a derivative of something like that? Well, it's called the chain rule. So if f of x and g of x are differentiable functions of x, then the derivative of their composition, so again an inside and outside function, is given by the following. Okay, so if we take the derivative with respect to x of the composition of a function, you take the derivative of the outside function and keep the inside function alone, times the derivative of the inside function. So this is the chain rule right here. Okay, that's the chain rule. Okay, let's try an example here. So again, kind of think about it as the inside and the outside function. So the inside is what we have in parentheses. The outside would be, we have something raised to the 25th power. So I'm trying to find the derivative of this. If I had, again, just something like y equals x raised to the 25th, this is our outside function, I would simply do power rule. I would do 25, bring it down in front, and I would decrease the exponent by 1, and typically we'd write x in there. However, we're not going to write x, we're going to leave our inside function, 3x squared minus 4x. Now, I'm going to take it times the derivative of the inside. Well, the derivative of the inside is, again, power rule, 6x minus 4. So again, this is the derivative of the outside function. Leaving the inside function. And then again, this is the chain portion of it, which is the derivative of the inside. And here's just another way to actually write the chain rule. Okay, just another way to kind of think about it. It's the general power rule if you use a function of x. Okay. Let's try a few more examples here of this chain rule. So again, kind of thinking about it as the inside function and the outside function. So we take the derivative, again, 9 multiplied by coefficient in front, which would be 1. I leave the inside function, decrease the exponent by 1, times the derivative of the inside function. So 15x to the 4th plus 4. So let's keep going with a few different types of examples here. Now we're going to bring in a trig function. If you recall, when we did 8.4, or trig derivatives, we discussed this notation is really taking the quantity cosine of x raised to the 4th power. We typically write the 4 on the cosine, so there's no confusion where the exponent is there. But the inside function in this case is cosine. The outside function is something raised to the 4th power. So when we take, again, this is derivative notation here, when we do dy dx of cosine the 4th of x, so again, bring it down in front, times, leaving cosine, the inside function alone, decreasing the exponent by 1. And now we take times the derivative of the inside function, which would be negative sine x. So that is our derivative. Okay, so now I want you to think about the difference between this, right, where cosine is the inside function, and our next example here. In this case, the inside function is x to the 5th. The outside function is sine of x. That's, again, the outside portion of it. Alright, so if we're taking the derivative, dy dx sine x to the 5th. Okay, so what's the derivative of the outside function? The outside function is sine, so that would be cosine, and then again we leave the inside function, times the derivative of the inside function, so derivative of x to the 5th, x to the 4th. That's our derivative. Alright. Okay. Now this one has a couple things going on here. Hopefully you recognize that we have two terms here, so we're going to be doing product rule. However, when we take the derivative of the second, we are going to be using chain rule because we have an inside function and an outside function. So product rule is first. Now we're taking derivative of the second. Derivative of the second is going to be doing the power rule. I'm sorry, chain rule. So 4 multiplies in front, leave your inside function, decrease your exponent by 1, times the derivative of the inside function, which would be 6x. So first times derivative of the second, plus second, times derivative of the first. Alright, so again we want to find the derivative here. In this case we have quotient rule, and then again within our quotient rule, when we take derivative of the numerator, we'll have to do chain rule. So derivative here, low d high, so derivative of the high is chain rule, 2 times 2x minus 4, raised to the first power, I'm not going to write that 1, times the derivative of the inside, minus high, derivative of the low, over low squared. Alright, and this concludes our first day of chain rule. We'll review over this the next day in class. Got a little video that I'm also going to show you, a little tutorial regarding the chain rule, but we'll spend a couple days on this. And again, just remember, think about it in terms of the inside function and the outside function.